So if you have any confusion so far, you can ask, because you are saying that you have a lot of confusions for assignment 1 and assignment 2.
Good evening, sir.
Yeah.
Actually, sir, I was just surfing again the website of NPTEL. Then again, I found that the solutions are not yet uploaded. And one of the question I was not able to do was of loading, which was not symmetrical. Like for varying load we are uniformly varying load and variable load, right? So I was not able to solve with variable load.
Okay, in case of beam, you are saying?
Yes, sir.
So, like, is that same question is there in the assignment, or you are?
Yes, sir. Yes, sir. In the assignment, it is given. I'm just searching the question number.
Okay. So I'll just share it. You can tell me that which one. Which one?
Yes, sir. The upper one.
This
Yes,
one.
sir. This. Yes, sir.
Okay. So I'll explain you with the solution itself. So it's a non-uniformly distributed load, as you can see, right? Because it's just following a function where W equals to W naught minus K excess cube, right? And
Yes, sir.
the value of W is given at x, like if you consider an axis with origin at this pin joint A with the x axis and that as the y axis, as it is given here, that x and W, so that at x equals to 0, this W is equals to 2400, right?
Yes, sir. Correct.
So if you put that 2400 equals to W naught minus at x equals to 0 means it's 0. That means W naught equals to 2400, right?
2,400.
Yeah. Now in the similar way, you do it for at x equals to 6. At x equals to 6, W equals to 1200. So 1200 is equals to W naught minus K into 6 cube, right?
So again, in this part, we are dividing the whole loading into two parts. First is your W0, that is 1200 minus 24 minus 1200. That is 1200 upper that varying load, right?
No. So okay, so you don't need to think in that way. So it's, let's say that this W is a function of x, okay, and you have given the two boundary conditions. So what I mean by boundary conditions is that you have the given that at x equals to 0, W equals to this, at x equals to 6, W equals to this. So
Okay.
okay, so you don't need to think in that way, that like you are just doing the like 2400 minus 12,000, so that's why it is 12,000. So it's not that. So let me share the solution there, you can get the more idea. So are you able to see my screen?
Yes, sir. Yes, sir.
Okay, so you look at this. So at x equals to 0, that W equals to 2400, right? So 2400 equals to W naught minus K excess cube, where x equals to 0, that means W naught equals to 2400. Okay, and in the other case, you have 1200 equal to W naught minus K excess cube, where x equals to 6, and the value of W naught equals to 2400.
2,400.
Yeah. So if you do that, you can get that K equals to 50 by 9.
50.
So from these two boundary, like using these two known values, you can calculate that what is the value of W naught and K, and this is your expression for W. The W equals to 2400 minus 50 by 9 into x cube. Okay. So now for any given value of x, you can calculate that what is the load at that point.
Okay, so only we need to solve by equation method, right?
Yeah.
So I was mistaking the.
And then the rest is simple. So the total load is the integration of W into dx. So at any elemental length dx, it will be W into dx, that the load at that elemental length, elemental length, then you just integrate it from 0 to 6. So the 0 to 6, because it's just the 0 to L, I mean 0 to up to the length of the beam. So it is so if you do that integration 0 to 6, if you do that integration of this function with respect to x, you will get is at 12.6 kilonewton. So because of that uniformly distributed load, because of this uniformly distributed load, the total load which that beam is experiencing is 12.6 kilonewton. That is there.
Okay.
Now the next question is, I know the total load, okay, I know that the how the load is varying, but this resultant load, that 12.6 kilonewton, at what point at what point it will pass through. So this is the resultant load, so that means it will pass through some point, right? I mean
Yes.
that resultant load, at like what distance it will act from the origin, from the point A, at what distance it will act. So how will you do that? It just simple calculations of the to finding the centroid of this load distribution. Okay,
Yes, sir.
so how will you find the centroid of the load distribution? Let's say that it is I mean this 12.6 kilonewton load will act at a distance which is x bar from this point A. Okay, it will, let's say, I mean that is the centroid of the load distribution.
Okay, sir.
So if I do that, that means about that point, if I take the moment that x bar into r, like if you see this equation, so r is the total load, so x bar into r, that will generate some moment, and the moment of a moment of that distributed load, if I multiply with x, so w dx was the load, x into w dx is the moment, right? So if I integrate
Yes.
that should give me the same result. So that means x bar into r is equals to 0 to 6 x w dx. That means x bar equals to 0 to 6 x w dx divided by r. So if you do that integral, it's coming to be 2.74 meter.
Sir, this is the application of Verigne's theorem, na, if I am not wrong.
It's not the Verigne's theorem. It's just the calculations of
Calculus form only. Okay. No,
Huh.
because I found that r into x bar is there. So, okay.
So
I got my note.
it's just the calculation of the centroid.
Okay, sir.
Okay, so like how will you calculate the centroid of area? Okay,
Yeah. Got it.
so just like for this problem, you know that the resultant force is acting, like it will act at the midpoint of this load, right? Like
Yes, sir.
that's how you are doing. But in
Yes,
this
sir.
case, it's
Yes,
not
sir.
a uniform.
On the centroid.
On the centroid you are calculating. Now the moment
Yes.
you calculate the centroid, the rest is easy. So you have three unknowns. What are the unknowns? That at the pin joint you will have the force in the x direction, force in the y direction,
Y direction.
and in the roller joint, I mean in the roller support, you will only have
Y,
the force in the
only
y
Y
direction.
direction.
So if you apply that fx equals to 0, fy equals to 0, and the moment is also equals to 0 about the point A, you can calculate that what is the value of that reaction force at all of these points. Okay.
Okay, sir.
So all these detailed solution, I think they I have already provided them, but I don't know why they are not uploading it. And
Okay.
I guess in the morning someone was saying, like in the afternoon someone was saying that there is some mistake in terms of like the options is not correct in the NPTEL, and the option which you selected is something which is correct. So that I will take care of. If you have done the right answer, you will get the marks. So there is nothing to worry.
Okay, sir.
And yeah, so do you have any other
Sir, may I ask some other doubt which is not related to our topic right now at this moment?
Yeah, sure.
Sir, actually, while going truss, graphical method.
Hmm.
I was facing that in graphical method uh, I was not able to give that particular magnitude
Hmm.
in graphical method. So how can you please explain it to me, because I was facing that problem.
So in the strass, you are solving like you are calculating the forces using different bodies using the graphical method.
Yes, actually, in the syllabus for FE, it was given that one of the method is graphical method. For that you have to do it for truss.
Hmm. Hmm.
So I was not able. Means I know the method is like you have to make the triangle forces, but I was not able to how to define how to give the compressive force in graphical method, or how to give the tension force, how to determine that forces in graphical method.
Okay. Okay. So in the graphical method, you have to be like a little bit strong in geometry. So I will like what I will suggest that the graphical methods, I don't think it is used like too much, but there are two main methods by which you should solve these stress problems. One is the method
Okay.
of joint and the method of section.
Sir,
And
those method I know actually, but for the assignment in SPPU, Pune University, they have given in mechanics.
hmm.
If you allow me, can I share my
Yeah, yeah, sure,
screen?
sure, sure, sure. Why not?
Just a
Share it.
moment.
Yeah. Oh, okay, okay. I see. So you are saying that it's the kind. So the graphical method in the Strauss as in it's in the subject of kinematics of machine, something like that.
No, sir, not
Oh,
in kinematics. But what they have done is in SPPU syllabus, they have given four graphical method. They have to solve as an assignment sort of thing.
okay.
For example, first one is find out the coplanar forces and their resultant in the coplanar forces for
Hmm.
two forces. I think two
Hmm.
forces. Yeah.
Hmm.
And next one is for more than two forces,
Okay.
non-concurrent system.
Hmm.
And
Hmm.
the third one is your trusses.
Hmm.
So I was not able. They have told to say at least two method a class should be discussed with.
Hmm.
So I was not able to discuss the trust method. And in that discussion, what I found was that I was not able to give that tension, whether this force is in tension, this member is in tension, or this member is in compression.
Okay. Okay. So you can share the screen and I can see the question if you.
Sir, question is not given. Actually, I was just showing you syllabus, and I don't know how I am not able to share my screen. Just a moment.
So
I just have an image of it. Question.
let me check if I have anything like that in any book. Let me also check. Mm,
Sir, it's no issue. Other time, also we can discuss this. Only just tell me how to solve this in easy way.
so actually, this graphical method I am also not too much of familiar with. But if you give me the problems, I can like solve it in it some other like some other method and
Okay,
try to.
sir. Some other time we can solve it. I will just give you, because I didn't get any proper value or proper type of question for graphical method even in other reference books.
Okay, okay, okay. So what are the
Okay.
like what is the reference book you are using? Can you tell me?
Sir, right now I just saw this in Hibler again, Baron Johnston, and one is Bansal.
Okay,
The
okay. So Hibler is a good book actually. So you should.
Yeah, Hibler is a good book actually.
So it is not there in Hibler. So I'm just sharing the Hibler's book. So 1 minute. Let me check.
Pardon, sir, I didn't get you.
I'm just sharing the book of the Hibler over you in the Meet. 1 minute. So, are you able to see the screen? Oh, instruction.
Yes, I am able to say this.
No, this is not the book. The solution is it? This is the solution. This is not the book. 1 minute. This is the book. Yeah, this is the solution manual actually. Okay, it's not there in Merriam and Craig. It's not there, is it?
Yes, sir.
So let me see if it is there in the Hibler, then I can explain it right now.
Hibler, I don't think so, sir. There it is given.
Okay. So the other book which I have, do you have this book by Rudra Pratap?
No, sir, I don't have this.
So let me check if I have that thing here. So it's the graphical method, like the Strauss problem using the graphical method,
And
right?
we have to find out the forces in the member and its nature using graphical method of
Okay,
of
okay,
trust.
okay. I see, I see. So let me check. It is in 238. Static stress is
Extremely sorry, sir. My screen is actually my laptop is hanged, so I'm not able to share my screen.
okay, no problem, no problem. So what you study? Are you doing BTech?
No, sir. Actually, I'm teaching in engineering mechanics subject for the Seagood College of Engineering. But the thing is, I was having a year gap between my work due to some reason, so I just started again.
Okay, okay, okay. So what you did? You did BTech and MTech, is it?
I did BTech and MTech.
Hmm.
And then I joined Seagood and then I worked for the 2 years and then I took a year and a half gap.
Okay.
And again I joined.
Hmm. Hmm. I see. I see. So this is a book, like a good book where you can get all elementary
So,
problems in
what is
classes.
the name of the book, please? Can you repeat?
It is by Rudra Pratap. Uh,
Rudra Pratap.
yeah.
Okay.
Okay. Let me. So this is the introduction to mechanics for engineer.
Okay. Sir, is it possible for you to share the soft copy? Because I don't think even in easyengineering.net can get this book.
So you just sent me your mail ID. I can,
Yes, sir.
or you can write my mail ID and then just send a mail that you need the book. I can share all the book and the detailed solution of the assignments also. The
Okay, sir, for sure. Sir, can you please tell me your mail ID then in that
hmm.
case?
Yeah, yeah, yeah. I'm just sharing. 1 minute. Yeah, I have just shared my mail ID in the message box.
Okay, sir.
So it's am17d700 at the rate smail.iitm.ac.in.
Okay, sir, got it.
So let me check if I have that similar problem here or not.
Sir, I have mentioned even mine. You will get this message from my side.
Okay, sure, 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 sure. So from where you did your BTech and MTech?
Sir, B from PDVP College of Engineering, and then from Raisoni I did my MTech.
Okay, okay. Like in which state?
2018, sir.
No, no. Which state? State.
Maharashtra, Maharashtra.
Okay, okay. Oh, okay. So you are from Maharashtra actually.
Yes, sir.
See, there like the method of joints, method of sections, and solving stresses on a computer, Fremson method for the after methods advances. Let me check. I don't think it will be there in this book also because so in this book you will get the detailed study of the basic stress problem. It's a very nice book. I'll send it to you, and also they have given the MATLAB code for all of the problems. It's like you can write the
Oh,
code
nice.
write the code of that problem in a computer like in MATLAB,
Okay.
and like it will give you the solution.
Okay.
So yeah, that's an advantage of this book.
Checking it in Hibbler if I get again, by in case if I am mistaken, because I have already seen this while teaching.
Hmm, hmm. So let me check if it is here in the Merriam and Craig also. Then if it is not there, then you can send me the question over mail also. That is also fine.
Okay, sir.
I'll try to solve.
Yes, sir.
So
That is the best way actually.
so 1 minute. So if it is there in that what you were saying, if it is there, method of stresses, method of joints, plane stresses. Okay, let me see. So this book is also good. It is the Merriam and Craig. So in this book you will get a lot of like problems. Other
Okay, sir.
and I think the most of the assignment problem which is there, it will be there in this book.
Okay,
Either
sir.
either it's in Merriam and Craig, or it's in Hibbler, or it's in that Rudra Pratap. Only from these three books you will get all the problem solving questions.
Okay, sir. Rudrapada, Hibbler, and the third one is?
That Merriam and Craig. So
Okay.
I'll again.
Sir, do you also have that Merriam book?
Yeah, I'll send you the all this book. So it is engineering
Oh,
mechanics. They have the two parts. The part one is the statics, and the part two is dynamics.
okay, sir. Thank you so much.
Okay. Okay, so you just send me all this over. I'll just send you all these over this thing. You just send me a
Okay.
mail by reminding that I have to send you the book. Then I can
Okay.
easily send it, and also you can send me the question questions where you have the problems to solve.
Okay, sir, for sure.
Okay, okay then.
Thank you so much, sir.
Okay, okay, no problem, no problem. Okay.
Thank you.